This video is going to be all about slope. What is slope and how do we identify or quantify it? So I wanted to start off with this beautiful landscape, mostly because it's beautiful. And in the distance of this beautiful waterside village is this mountain. And when we think about slope, a lot of people think about steepness, right? So that's really how we're going to approach this at first. From a graphical perspective, we're going to talk about slope in terms of steepness of a line. But know that that's only really one perspective on it. So let's get back into our definition. The definition of slope is going to be a constant rate of change. So go ahead and get this all into your notes. Slope is a constant rate of change. The formula that you should be familiar with for slope is change in rise over change in run. So make sure we get all of this. Off on the side, we want to put that triangle equals change. And of course, change implies subtraction. Also keep in mind that this triangle is the Greek letter for delta. Delta means change. Change means subtraction. So if we're talking about change in rise, we're talking about change in y's. y2 minus y1 all over x2 minus x sub 1. If we're talking about two sets of points, then we must have an x and a y for both of them. And to delineate between who's who, we're going to need an x1 and a y1 and an x2 and a y sub 2. So the first thing we want to ever do when we see two sets of points is to label the points accordingly so that we don't mess up our order. Order matters, especially when it comes to subtraction. First, I want you to take notice that we are working off of assignment 17, identifying slope. This is not, I repeat, this is not the packet that you got, but notice it's very similar. So we are going to work off of this, and I should give you an example of everything that's on the packet. So again, careful notes will be helpful. Take a moment now and read the instructions here. Find the slope of the line through each pair of points. You should write the formula on the sheet for reference, right? And keep in mind that labeling your points will help you to avoid costly sign errors. That being said, let's go ahead and let's label our points, x sub 1 and so on. You go ahead and press pause now. Label yours on your paper. The next thing I suggest was writing the slope formula. So slope equals y2 minus y1 over x2 minus x1. This will be very helpful because now basically the rest of this is simply copying. I'm going to get right into the work. M equals, and I look over here, calls for y2. I look over here, y2 is 10. So I write 10. Then the formula shows that minus is part of the formula, so I'm going to write minus. And then y1 is 16, so I'm going to write 16, just copying. X sub 2 is negative 1. The formula calls for a minus. X sub 1 is 4. Now, it's just about careful order of operations. I'm going to do the top part here. These are implied parentheses. 10 minus 16 is negative 6. And down at the bottom, negative 1 minus 4. If I get two negatives in a row, I got a bigger, larger negative. And then, keep in mind, I'm going to simplify my answer. A negative divided by a negative is a positive. So I have a final answer of 6/5. Now, press pause, take a moment, draw a quick sketch of these 2 points. Draw a quick little hand sketch of 4/16 and negative 1/10. Press pause now. Doesn't have to be a perfect drawing, just enough to get the point. So 4/16 is right here, and negative 1/10 is right here. And all we're saying is that the change in height here is this value of 6. This is positive 6. And the horizontal change here is this positive 5 right here. So all we're saying is up 6, right 5, up 6, right 5. describes the steepness of that line. Remember our beautiful landscape? What describes this steepness or this steepness over here? Sometimes climbers would refer to that as pitch. On the roof of a house also, pitch. So that's why I say pictorially in this situation, we're referring to it as steepness. So the constant rate of change is sort of like a stepping system, like that. Okay, your turn. Follow the simple set of directions. First, label these points, -3, 7, and 5, -9, x sub 1, y sub 1. Write the formula for the slope, substitute in your known values, evaluate and simplify your answer, draw a quick sketch. Press pause now and do all of that. Okay, just a little quick sneak peek. Notice on the bottom here, I have 5 minus a -3. Just because the 3 is a negative doesn't mean that that's the subtraction part of our formula. It's still minus whatever that x sub 1 value is. And it doesn't matter if I had labeled the first set of points x2, y2 and the second set x1, y1. The order in which I do this won't matter as long as I simplify that answer. It's big to simplify. Keep going. This is not simplified yet. Press pause. Don't cheat. I get a final answer of -2 or -2/1, but really fully simplified is -2. Now draw a quick sketch and notice that my slope is negative. Okay, sketch it up and see if that jives. Okay, make sure your sketch is in your set of notes here, and notice as I move from left to right on this line, as I move from the left side towards the right side, the line goes down. That's what a negative slope will do. Negative slope, the line moves down. Positive slope, and like in our last question, the line moved up. The next one you're going to complete on your own and show that final answer for credit for taking notes on this video. For this problem, I want you to complete the full process as noted right here, just like we did in the last two problems. You're going to show this as part of your notes. You've got to have it all there to get credit for it. Not to mention, it's just the right thing to do to grow and learn. That's why we're watching the video. Moving right along, the next way to identify or calculate the slope is to use a picture. If we've been given a picture, this is what we're going to do. We're going to go moving from left to right, always moving from left to right. I'm going to look at the first point given and just calculate the total vertical distance it takes to get to this point over here. Then I'm going to calculate the total horizontal distance. Again, what I'm doing is calculating that change in rise, which is change in y's, over change in run, which is change in x. So let's take a look. Right here, our total change in vertical distance. Since I'm moving, as I go from left to right, this line is going up. This vertical distance, going from this point to the point over on the right, is going up +2. And then our total horizontal distance is 2 blocks here and 4 blocks here. And each block, or square, or grid, whatever you want to call it, hop is 1 unit. So a 6-unit hop all the way across. So our change in rise is a +2, and our change in run is a +6. Now notice up here, we should always answer in simplified terms, so our slope is going to be 1/3. And there's a video on simplifying fractions earlier in the list if you want to scroll down and rewatch that. And you'll see why there was a method to our madness and how we rolled out all of these videos. Let's keep going. Okay, a new problem. I see that my line is going down. As I move from left to right, this goes down. So I'm going to start at my furthest left point and count how many units it goes down. So that's 1, 2, 3, 4, 5, 6 units down. And since I'm moving down, I'm going to write -6. And as I move to the right, 1, 2, 3, 4 units. That's change in y's is -6. My change in x values, +4, which is -3/2. So that's my simplified final answer. Let's try again. In this one, again, we see that we have a negative slope because the line is moving down. So starting from left to the right, I'm going to go down 1 unit, so that's a -1. And I'm going to go to the right 1, 2, 3. -1 is my change in rise. 3 is my change in run. So I have a slope of -1/3. There is no simplification for this one. It's already in simplified terms. You're going to try 2 for your own in your notes. Hand those final answers in for full credit. Okay, I have you all set up. You have 2 problems here, here, and here. We want a simplified answer, and we want your original change in y and change in x values. After that, move on to the next problem. Okay, hopefully you've finished up your graphing problem work. Now we're on our last piece, and this is mostly identifying, right? So we're taking a look and being sure to use proper symbolic terminology. Slope is defined as m. So when I look at slope-intercept form, and yes, please put this into your notes. When I look at slope-intercept form, the coefficient of x is my slope. And here we are. The coefficient of x is my slope. Who is that coefficient? Right there, the number in front of the variable. So what I've provided now is 4 examples. So we're going to take a look at this first example here. mx, my slope right here, the coefficient of x is -8/5. So m is equal to -8/5. And then in my next example, my slope, again, coefficient of x is just the negative sign, but that's negative what in front of that x? Technically, there's a 1 right there, so my slope is -1. And for my last problem, my slope is -1/4. The only thing you got to be careful about is to just not forget the sign. Go slow, easy, careful. All right, in this last problem here, I have x equals -1/4. This is not in slope-intercept form. What kind of line is this? This is a special case. This is a vertical line. And I know because it's in x equals form. So the slope for this particular piece, we're going to call the empty set or undefined. And for lack of space, I'm just saying over here that this is the abbreviation for undefined. The empty set is a nice mathematical, symbolical way to write that it is undefined. All right, I'm going to give you a couple more, and then that should wrap it up. So these last 3 are for you. 1, 2, 3. Carefully just label m is equal to, m is equal to, m is equal to, and you're all set. Hopefully now you have a better understanding about slope, what it is by definition, right, a constant rate of change, and how to identify or quantify it. All right, you have all the tools you need to work on assignment 17. Good luck.